This is insane. I just had to film this effect. I built this very sensitive receiver coil here, and we're able to very dimly light an LED, but this isn't what I wanted to show. We're at a 1 milliamp input now on the system. 1 milliamp input for wireless power output at such an insane range. 1 milliamp input. I can't get over how insane that is. And yet we have wireless power at incredible distance. The circuit is earth grounded at the hut side. We still have phenomenal wireless power effects. And in case you doubt it's coming from that system, it's unplugged. It's dead. Can't even tell it was on because it virtually consumes no power. Consumes 1 milliamp at 13.4 volts DC. That's the input. It's unplugged now. I'll plug it back in. And to get it oscillating, sometimes it doesn't always come on. And to get it oscillating, you might have to touch the transistor, and it comes on dimly. So we have a 1 milliamp input. And I don't know what's going on with my phone, but just bringing my phone near this thing makes it act weird, even though we're at virtually no power input. Very simple circuit. Using a battery this time for testing instead of the supercap hybrids. Just a regular 12.8 volt, 6 amp hour, Lifey battery. The positive output connected directly to the modified ringer circuit. Negative is passing through an analog amp meter. A analog milliamp meter passes in series through our resonant choke coil that chokes our power back. We inserted 4 met glass laced ferrite rods in the center to tune it even more, to reduce the power. I don't know why that happened, but putting those in the center reduced the power further. The negative connection is in series with that bifilar wound resonant coil. If you were to unwind this coil, the yellow wire would fit over the 6.5 inch. The coils all measure 6.5 inches. If you were to wrap that yellow coil around here, it would take up 6.5 inches. And there's just 2 of those bifilar connected. And then I added a 50K carbon film potentiometer to fine tune the resistance even further to reduce my input to 1 milliamp. So that's how I got the input to 1 milliamp. Was with that choke coil, the ferrite rods for inductive tuning, and an additional very weak ceramic magnet that I can slide across the rod for tuning. That magnet is very important for inductively tuning the device. It has to be an extremely weak magnet. And I just can't get over how insane that is. I think I'll shut my light off and let you appreciate that. So, we have a 1 milliamp input to the wireless system, yet we have a wireless power output. And I have read excess power in this system, excess wireless power. And keep in mind, I'm doing this wirelessly. That's the distance on it. About 8 inches. And I can still bring these guys close. It's just insane. I've never seen anything that efficient. And for some reason, the battery is very active. There's a wireless field around the battery. Basically around the entire circuitry, there's a wireless field. At 1 milliamp input. I can increase this brightness here by connecting a just another full bridge rectifier between two earth connections, and I can increase the brightness of this LED at no additional power input cost to us at all. So hopefully you see that that got a little bit brighter. Got a little bit brighter. And I can also tune the I can also move the coil to tune it more. So I have a 1 milliamp input. That is my input to the system. 1 milliamp. And you know, that's my wireless output now. You see why it's getting exciting? This is a virtually no input system for an excess wireless output power gained system. And the earth connection is right here. Heavy earth connection to my heater down there. I'll turn the light on again and show you everything in full. And I can get this even brighter if I were to connect the other end of this rectifier, because this rectifier is open circuit now. It's going between an earth connection and a virtual earth. I have to connect this now. If I were to connect this to another resonant coil and bring this close to the battery, it will get brighter, as you see. So that LED light is extremely bright. That is an extremely bright LED light. Dare I say we're consuming over 1 milliamp. I would say that output is possibly greater than the input. That is our input still locked at 1 milliamp via the potentiometer. And keep in mind, this output, this wireless output, is probably over the break-even point of our input. And we still have phenomenal wireless power at no degradation. Look at this. It even gets brighter. Everything gets brighter. This is where it gets crazy. I take another resonant coil. I just bring it near the system, and I will connect it in parallel to the other resonant coil, and things will get brighter. See that? Got even brighter. Even brighter. Looks like it wants to burst now. Oh my god, that's bright. Extremely bright. Our input still locked at 1 milliamp. In fact, I think our input went down even more, because the more of a wireless load you put on this system, the more the input power to the transmitter drops, which is very strange. So we're at a 1 milliamp input on the system. We have a combined wireless power output that's probably far in excess of our input. That LED looks like it's about to burst. He's definitely consuming more than 1 milliamp. And on top of that, we have phenomenal wireless power. To the point where it hurts your head. So I'll turn my light on again, give you a tour of the room. Nice good peek under the desk. Nothing under the desk. My toolbox. Heavy earth ground connection is where the circuit terminates into. You can zoom in. My phone acts weird near this thing. Take a peek on the workshop. Full room tour. and packaging up a lot of things and shipping out everything very quick. So I build everything from in here and just ship it out, so nothing crazy going on in the room. I work in a very small room. That looks like it wants to burst. You're seeing everything in real time. Our power consumption, less than 1 milliamp. And again, the way you fine tune that is you just build a Super Joule Ringer 3.0 circuit exactly the way that was in Laser Hacker's schematic or Laser Sabers. I used a 8-inch long Met glass lace Type 77 nickel zinc ferrite rod. All the coils are 6.5 inches long to be a golden ratio harmonic. The primary in this case, which was the thin coil, is 28 gauge high quality, wound to be 6.5 inches long when on the rod. The secondary has to be a thick coil, which is 16 gauge now, wound in the opposite direction for a bucking configuration. It has to be that way or it will blow up. The transistor is a 2N3055 now, more efficient. I heavily earth ground the high voltage hot side of the circuit, the output, to make the system more efficient, and it's doing something interesting with the resonance where we get the magical wireless power effect once it's earth grounded here on the hot side. So I'll walk you through the system. It runs off a 14 volt DC battery, can't be higher than that. The positive connection goes straight to the positive connection of the circuit, the coil, the 16 gauge coil. The negative passes through a milliamp analog current meter. The negative passes again through a resonantly wound bifilar coil with the 4 Met glass laced rods to sit in the center to inductively tune it. A potentiometer in series, a 0 to 50K 5 watt carbon film potentiometer, and that just connects to our transistor for the circuit. See, I disconnect it, our wireless power ends, and it's not even like we're consuming current in the system now. When you reconnect it, sometimes you might have trouble getting it to oscillate. Touch the transistor and it will come on because you earth grounded it with your body via capacitive coupling. So that's how you can trick it into coming on in this low power mode, which seems to be the way to go because we're at virtually no input, yet we have phenomenal wireless power output. And this tuning magnet here is very important. I can just slide this to adjust my output, and I saw my current go up a bit, and I want to get that back right where it was, right there. I believe I had it tuned so perfect it was less than a 1 milliamp input. And in case you think that meter's wrong or not working, if I detune the system by touching the battery here, you see I'm touching the battery, I'm detuning the system, and therefore you see a current drain on the meter. In fact, my light even gets dimmer when I do that. I touch the battery, I detune the system, I consume more power, and my wireless light gets dimmer. So go figure. I'm going to zoom in on that, really show you that effect. Touching the battery, not touching the battery, touching the battery, not touching the battery, touching the battery, not touching the battery. We'll do that effect again on the wireless output light. Touching the battery, not touching, touching, not touching. So we consume more power and the light gets dimmer, which is very interesting, the wireless light. So this is what I wanted to document. This is what I wanted to show. It got even simpler. We can disconnect everything. I can show you everything. I'll move my multimeter. It's not too messy up here. This other rectifier is just grounded into my power supply that's off. These leads aren't being used, they're not going anywhere. I can just start removing things and disconnecting. So it really, again, we set up another rectifier between a separate earth connection. The AC side of this rectifier goes between an earth connection and these two resonant pickup coils in parallel. And I will connect these to the light again, and we have phenomenal wireless power, almost to the point where the light wants to burst. Never seen that happen before at no input. Doing that does not increase our input at all. Nothing at all. And you can tune it even further with that magnet by sliding it across the device. Very weak ceramic magnet. Again, I'll disconnect system, hook it back up, have to touch it to start the oscillation, and there it goes. But figured I'd show that. It's insane. Never had those effects happen before. I'll show you the other crazy thing. So keep in mind, this output probably exceeds the input while also having wireless power. You can create almost unlimited wireless LED lighting, which is just insane. This is just a slab of metal that came from one of my friend's machine presses. And watch this. How is that possible? At less than 1 milliamp input? How do I have this much wireless power at less than a 1 milliamp input? This is a breakthrough worth studying. Everyone needs to study this, because you can combine all this wireless power and charge batteries and do whatever you want with it, or put it in capacitors. It's already at the point where your jaw will drop. And in fact, I have another transistor here, so you can even look at it. That's the exact model. Get a very good look at it. 2N3055. So yeah, now I'm going to show you the more interesting thing. Move all this crap away. Everything is can be easily disassembled. So I'll just get all this out of the way. Put that off to the side. So here's the interesting thing. I'm going to try and get this thing tuned up to nearly no power consumption. Ooh. Should probably do this off camera, but I don't like cutting anything. There's always going to be that one person that complains. And I'm tuning the potentiometer. Oh, there we go, we got it on. Got it on now at virtually no power input. Yup, we're back to stupid efficiency levels. It's either anywhere from 1 to 3 milliamps now. I can't get it quite as fine-tuned as I just had it when I slid that magnet earlier, but that's still stupidly impressive. And this is what I wanted to show. I made a very sensitive receiver coil. It's 4 individually wrapped coils, all terminating to the same diodes, composed of, well, actually I have them over here, I don't have to guess. They're very sensitive diodes. They're these. I believe they're 1N4148. But anyway, here's our wireless power range at less than 1 milliamp. And I can get it even further. We're at the edge of the table. And look at that. And this video is nearing its end. We're at the edge of the table, and that's our range. And yet we still have this effect. And I can take an earth ground connection too. Oh wait, that's connected to the rectifier, whoops. I'll disconnect that old rectifier. And adding an earth connection causes it to get a little brighter, but not as much when we had the other rectifier in parallel with it. So that's all I wanted to show, and thank you everybody for the people that subscribe. Thank you for all the supporters. Now, the way you actually use this power and make it useful is instead of running in that LED, you would charge up these capacitors and pulse discharge them with a real simple timing circuit. And you can do whatever you want. Charge 9-volt batteries, 12-volt batteries at virtually no input cost to your transmitter, which is very interesting. So, yeah, thank you everybody. Phenomenal breakthrough. Yeah, that's that, and we will see you on the next one. Thank you.